Hi, everyone. My name's Josh Stella. I am the CTO and co-founder of Fugue. And what we do at Fugue is we secure our customers' cloud infrastructure, and we spend a lot of time here picking apart how bad guys actually break in and steal stuff, how hackers exploit you in the cloud, which is a very common exploitation attack surface now, is cloud misconfiguration. So what we're going to do today is first talk a little bit about what is cloud misconfiguration risk. And then I'm going to break into one of my own cloud accounts and steal data out of it using the same techniques that we know a hacker used against a major bank last year by a DOJ filing. So I'm going to show you how a hacker thinks and how they go after your stuff. And it's a lot of fun. And hopefully I won't fat finger anything because it's going to be a live, real demonstration. All right. Then we're going to talk about some actionable steps to secure this as your customers, to secure your cloud environments. And we're recording this, so there won't be like live Q&A, but I'm always happy to answer any questions, offline or whatever mechanism we come up with. I'm just josh@fugue.co. I'll put my email address up at the end. All right, not too many slides, okay? We're gonna have a few slides and then we're gonna get into the fun stuff, but we do have a few slides. So what is cloud misconfiguration? Well, it's a major security risk. Cloud misconfiguration is having the cloud services in AWS or Azure or GCP, whatever cloud you're using, configured in a way that bad guys can take advantage of and get to stuff you don't want them to get to. That's kind of our definition of misconfiguration. And it is the main attack surface on the cloud. So every year we at Fugue do a big survey of hundreds of organizations that are operating on the cloud. And the survey is just about how they're thinking about cloud misconfiguration and what their concerns are. So 84% this year, this was done in 2020, 84% are concerned they've been hacked and don't know about it. This is good that people are worried about this. It's not good that it happens because it does happen a lot, but it's good that people are concerned about it. The simulation I'm going to do is based on the Capital One breach of last year. And in that breach, the only reason anyone found out about it was because the hacker bragged about it on social media. Like months after, or at least a month after, nobody had noticed it. Well, why is that? That seems crazy. I'm going to explain to you why that is when I simulate the breach. So 84% are worried that's happened to them and they don't know it. You should be in that 84%. You should believe that this has happened to you because it quite possibly has. 92% are concerned they're vulnerable to a cloud breach. This is actually down 1% from the same survey we did the year before, where this is 93%. This should be 100%. You are almost certainly vulnerable to a major cloud breach. And I'm going to show you that the way hackers think, they don't care about your compliance policies. They don't care about the ways that you've predicted they're going to come after you. They find ways. So you should be worried about it, okay? They're clever. There's a reason we call hackers hackers. They are creative. The original term hacking meant like doing something really skilled on a computer. And now that means breaking into stuff because guess what? They're smart, they're clever, and it's also fun. All right, so misconfiguration risk will increase or stay the same this year. The 76% said increase. It is always increasing. Every time someone in your organization puts a resource in the cloud, that is additional attack surface. Every time a cloud service provider creates a new service type, that's new attack surface. So it is by definition objectively growing all the time. So this is an increasing problem and it is not going to go away. All right, so Dave Linthicum from InfoWorld wrote an article in which he said, I'm seeing a lot of cloud misconfiguration in the real world, and it's scaring the hell out of me. It should be scaring all of us. We should be very concerned with this because it's really a new domain in security. Putting network monitors on your network endpoints and trying to create perimeters of defense in depth will fail you in the cloud. So the last 30 years of data center style security is going to help you only a little bit. There's a whole new way you have to think about this because the hackers are thinking about it a whole new way. Okay, in our survey, we asked the respondents, and these are all organizations operating at large scale in cloud. We asked them, what kinds of misconfigurations are you worried about? And I was really impressed with the responses, actually. I didn't expect this, but I should have known. There's so many smart people in this field that it made me really happy. If you read the news, who almost always get it wrong when it comes to cloud attacks, you would think that this object storage access policies, this third place contender would be number one. S3 bucket gets breached. That's always what makes the news. What doesn't make the news is how they get breached, okay? Data got stolen, not usually because somebody just left a object storage bucket wide open, but because of things like misconfigured identity and access management. That was our number one answer from our respondents. So on point. IAM is itself a network in the cloud. It's not just about like the identity of users. It's how the cloud resources talk to each other. And in the exploit I'm going to show you, I'm going to leverage IAM and our number two, bad security group rules. I'm going to leverage those two things to steal data out of S3. Okay, so it's all of them to do this hack. All right, cloud misconfiguration is very often overlooked. And there are good reasons for this. When I see cloud breaches in the news, but prior to founding Fugue, I was at AWS as a principal solutions architect working in like DoD, national security stuff in the US. Okay, so my background for about a decade has just been around building functional and secure infrastructure in the cloud. And I'm really familiar with the whole evolution of it as a result because I've been on the front lines. And what I've seen is that many dangerous cloud misconfigurations are not recognized as misconfigurations at all. One of the reasons for this is the compliance frameworks that people rely upon, like NIST and CIS and HIPAA and GDPR, and there's a long list, SOC 2. They're behind the times. The bad guys, the hackers, don't care about those things. I mean, they're really good to do. I mean, we at Fugue will let you see how you stack up against all those compliance frameworks. They're really good, but they're incomplete and they're losing the race with the bad guys. So the reason the security teams often aren't aware, or the engineering teams, DevOps teams, aren't aware they have misconfigurations is they're relying on experts building compliance frameworks to tell them what's dangerous, but those things are behind. And therefore, these are exceedingly common in enterprise cloud environments. Neil McDonald at Gartner, we use this quote. I have mixed feelings about it. It's true. So the quote is, nearly all successful attacks on cloud services are the result of customer misconfiguration, mismanagement, and mistakes. That sounds really kind of pejorative and punitive. Like if you were smarter, you wouldn't have gotten breached. And while in theory that's true, in practice, this is a vastly complex subject. And people who are excellent at it, I mean, I have very good friends over at Capital One that are in their engine, and I know how good they are. They're very good, and they got breached. So this is non-trivial stuff. And yes, it is kind of glib to say a customer misconfiguration caused this, but when you have literally potentially billions of misconfigurations, it's really easy to miss them. Okay. A little bit about how hackers find you and find the door into your organization. So in the old days, in kind of the Hollywood version of a hack, right? The bad guys, so the hackers like, okay, I want to go after this organization. I'm going to go after Acme Corp. And so I'm going to look at all of Acme Corp's stuff and try to find a way in. And this does happen. It continues to happen. One famous example of a number of years back is, Sony Pictures made a movie that North Korea didn't like. And they used spear phishing and phishing techniques to steal all the email out of Sony and embarrass the executives. And, so that's like the classic, we're going to target Sony and find a way in and hit Sony. That is not how most of these happen anymore. That's mostly Hollywood, except for rare cases. These days, what the bad guys do, what the hackers do, is they have automation that's running 24/7, looking for any object that appears on the internet, any IP address, anything with a DNS record. They're just hitting them all, looking for anything they know is a misconfiguration. Typically, well, John Breeden here in CSO Online says skilled or well-funded hacker groups, or both, many are both, are employing automation to discover and exploit misconfigured cloud assets within hours of their deployment. He's wrong. It's minutes. Typically, somewhere around 7 minutes is normal, and it can be seconds. So you have basically zero time to react as a human being to somebody finding and exploiting your cloud resources. So how it works now is the bad guys are running this automation. It runs 24/7. They get up in the morning, they grab a coffee, and they go look at the list of people's stuff they can steal and say, oh, that one looks good. And they already know the misconfiguration is there, okay? So you have to be very concerned with this, not just being thorough, but being fast and being quick to react, because that's what they're doing. Okay, therefore your security strategy has to evolve. And before the cloud, the world worked roughly like this, in the kind of data center world, co-location world, whatever you want to call it. Pre-cloud, pre-API driven infrastructure. You would do procurements, and you would go to vendors. You might talk to Dell and HPE and someone else for some servers, or Cisco and someone else for some switches. And you would design something, and you would build out your infrastructure, and that would run for somewhere around 3 to 5 years before any individual piece of equipment was recapitalized. So the network and security and operations teams would deliver this infrastructure to the application teams, right? And then they would live within it. And of course, they would add to it, or they would remove some things. But for the most part, that pre-cloud is very slow moving. It takes weeks or months to go through these procurement cycles to build this stuff. And then apps are kind of stuffed into what was built. And so in this world, things like network analysis and threat detection tools were used as the primary mechanism to identify intrusions, and then humans would respond to them through some ticketing system. That is totally inadequate to cloud, and here's why. In cloud, you don't go build all the infrastructure and then let your developers into it. The developers are building the infrastructure as they go. This whole thing is flipped on its head, right? Infrastructure is now, or should be, in cloud. If you're not doing it this way, you're losing a lot of the advantages of cloud. But the way it works now is when I go build an application, I'm a software developer, software architect for a long, long time. I'm going to, as part of building my app, build its infrastructure, or at least much of it. So that might be, this morning, earlier, I was building out a global network, and that took me a few minutes. To build a global network in the past would have taken large teams months, right? So this is a great thing because I can go really fast and I can deploy quickly. But it also means that I have to be worried about securing it along the way. So in this world, rather than there being this kind of network analysis and IDS and all this stuff, I mean, you might want to do some of that still. But mainly what you're going to be worried about is checking the configuration of that cloud infrastructure. Remember those comments that most of these breaches are due to misconfiguration, not due to the traditional ways that hackers would get in. So you can use things like policy as code validation tools. okay? And you want automation on your side for detection and remediation as well. So what this really means is that cloud security is a software engineering problem. It's a computer science problem, not a security analysis problem in the traditional sense. All right, let's get to, so I promised not that many slides. That wasn't too many slides, but now we're gonna break in and steal some stuff. All right, so this diagram is part of the product we make. The reason I'm bringing it up is to show you what I'm going to do here, okay? So over on the left is the internet. And here are some VPC networks, virtual private cloud networks. I've got an internet gateway. So this is a topology of a cloud infrastructure. And we at Fugue like to automate the building of these diagrams so that you can understand what's going on, right? So what I'm going to do today is I'm going to break into a compute instance, in this case, an EC2 instance. And I want to steal data out of this S3 bucket. That's my job. I want to get in and steal data. Okay. If I'm a bad guy, I'm going to be using, and you can see I've given this EC2 instance the very witty name, not really. I've got a CVE. Okay, so what's a CVE? A CVE, I always forget what the E stands for, but it's a common vulnerability. There's a database of these. It means like this compute instance has vulnerable stuff on it. Remember, the bad guys are using automation to find vulnerabilities. Well, this server, this EC2 instance, has one of those vulnerabilities. Now, if I were doing a like 100% accurate hacking demo, I would use some exploitative software to take advantage of a CVE. Maybe that is, for example, running scripts against the HTTP endpoint of the web server that has a known vulnerability and shoving some data in there that allows me to shell. That isn't too uncommon. I'm not going to do that today because having worked at AWS, I know those guys are watching all the time. And that's the kind of thing they notice, and they will shut you out if they catch you. And I don't want to risk that because then I won't be able to do my demo. Okay. So the very first part of this hack, I'm just going to kind of simulate by shelling in, just getting shelled. All right. So I've now shelled into that EC2 instance, and what you're seeing is my terminal. If you're not used to working in terminals, don't worry about it. Every single step I take, I'm going to explain in a way that you'll be able to understand. But I want to show you what it's really like to be the hacker trying to get in. All right, I showed you that diagram a second ago. The hacker doesn't have that diagram. They just know they got to one little place in your cloud infrastructure. And this is a theme I'm going to repeat over and again. You need to be aware of everything in your cloud infrastructure, and you need to be denying the hacker knowledge of as much as you can, because 80% of the job in hacking is gaining information, is doing discovery, okay? So you want total visibility. That's why Fugue gives you those diagrams, and you want the hacker to have zero visibility if possible. Okay, so here is an indication right away. This is just the banner for the Amazon Linux distribution. Perfectly good Linux distribution. It's actually quite a good Linux distribution. But I have forgotten to update it, okay? And by the way, if you go scan your whole environment using Fugue or something like us, you're probably going to find stuff that you've forgotten about and that is not up to current patch levels. So here you can see that 22 packages need updating for security. Each one of those is a potential vulnerability, okay? Out of almost 100 updates that are available. So this is why in the particular breach we're simulating, the bad guy first gets in. It's actually not a big part of the hack. It's a small part of the hack, but it's the first step in the door. There was an open SSH port or an open dangerous port, an unpatched server. with a known vulnerability, and now I'm into your account. I have no idea where your data lives. So I'm going to start exploring to see if I can find your data to steal. So I'm a cloud hacker, so I know what I'm doing. So I'm going to use the AWS command line interface command, which is AWS. I'm going to point to S3, which is where a lot of data is stored. That's what I want to get to. I want to get to S3. And I'm just going to try to do a list of what S3 buckets are out there. So AWS S3 LS is the command I'm going to run first. Interesting. So somebody did their job. I, as a bad guy, have now run into a problem. I am getting an access denied on the S3 list. So I don't have permission to list S3 from that EC2 instance. Now I'm going to switch back to my diagram here and show you why that is and how that works. Okay, if you notice, I just selected this EC2 instance. And the very first thing I see is that it has the IAM instance profile of maintenance role. Okay, just to explain what's going on here. In AWS, remember we talked about IAM being a major attack surface, being a dangerous service, and something that misconfigurations are really devastating if you have them in. A big part of the reason for that is IAM in AWS is more like a network than just identity. It determines, when you assign resources IAM roles, it determines what they're allowed to see elsewhere in the infrastructure. So this maintenance role here apparently does not have permission to see this S3 stuff over here. So as a bad guy, I've got to start getting creative. Now, I don't know. I just showed you in the nice Fugue diagram. I'm copying some commands over here. I just showed you in the nice Fugue diagram that there is a maintenance role on that instance, but the hacker still doesn't know that. So I am going to start exploring the infamous metadata service. This is another place where the press really gets things wrong, okay? All I'm doing here is a command called curl. Curl is like pointing your terminal at a website the same way you would type a web address into a browser. I'm going to do it at a terminal to get data back rather than to paint a web page, okay? But it's the same thing. And I'm calling this special IP address 169.254.169.254. That's the same on every EC2 instance. And what it is, so when you think about what is cloud, cloud is made of things like virtual machines and containers and functions, but they're living underneath what's called a hypervisor, okay? And a hypervisor is what manages those virtual compute instances of various forms. Now, in AWS, 169.254.169.254 is the hypervisor. Okay, you're asking the thing that's managing your compute instance for some information, and it knows some stuff about your compute instance. This is actually an awesome service, and if used properly, will help your security. You should not be afraid of it, but you should know how to use it. Okay, so as a bad guy here, I'm going to go look at this, and I want to look at the latest metadata. Just give me a list. All right, there's a bunch of stuff here. I can look at the AMI ID, the machine image ID, host name, whatever, the MAC address, all kinds of data. Well, you can imagine how this stuff would be really helpful when you're building particularly immutable infrastructure, which is the only way to go on cloud applications. You have automatic access. You don't have to go figure it out. You don't have to go sending messages across services or anything like that. It's right there in the hypervisor. But what I'm looking for as the bad guy doing discovery is I'm looking for the IAM security credentials. And I happen to know where those live. Let me move my little Zoom thing here. So again, 169.254.169.254. latest metadata. We went there, right? But now we're drilling down into IAM and we're looking at security credentials. And this will tell us what role we are running as. And you can see here, we showed this in the Fugue diagram, but I said the bad guy didn't know. Well, now the bad guy knows. It's maintenance role, okay? Now, I know the content, I know the role I'm running under, and I know from when I did my S3 ls command that maintenance role ain't going to help me get to S3. But I want to show you one more thing because the press has often gotten this wrong. And I've been disappointed. A lot of people have gotten this wrong. They said, oh my God, if you get into the metadata service, bad guys can attack you. Not if you do it right. So I'm going to now I'm going to drill in further. So I'm going to go the same place I went before using curl, and I'm going to go into the maintenance role itself. Okay, here we go. This looks scary, right? I've got an access key. I've got a secret access key. I've got a token. This is everything I need as a bad guy to still not have access to S3. So what? Right? The danger is when you can traverse the IAM network to S3. Well, we can't. So these credentials, as scary looking as this is, aren't going to help me as a bad guy one iota. In fact, I need to take a completely different approach now. So I know I don't have access to S3 using maintenance role, but maybe, just maybe, I can get to some other stuff that, perhaps people left open for me. So here I'm again using the AWS command line, but I'm not pointing at S3, I'm pointing at IAM. And I'm going to list the policies, and I'm going to search that list for any policy name that has S3 in it. Okay, so I'm not querying S3. I know I'm going to get an access denied there. I'm instead looking at IAM. And all I'm doing right here, by the way, I don't need write permissions to IAM. I just need list permissions to IAM. All I'm trying to do is list policies. If you think list permissions aren't scary and bad guys and hackers can't exploit them, you are very, very wrong. I am trying to do discovery, and I'm going to do that through list commands. Okay, let's hit enter on that. By the way, this is all real and live. Okay, so if I screw something up, I'll tell you and I'll go back. But so far, so good. We just executed that command against the AWS APIs, and I'm looking at this S3 read write as a pretty attractive looking policy. You can see here a list of policy names. S3 read write sounds like it would do what I want to do. So now I'm going to change tack again. I started out trying to get to S3. I got an access denied, so I started looking around and doing discovery in IAM. But now I know, okay, the thing I'm trying to do now is change this to the S3 read write from the maintenance role. Well, in other words, I want different permissions that this compute instance, this EC2 instance has. I want it to change its permissions to be able to see S3. And so I need to change what IAM role it is associated to. And that is called an IAM instance profile association. So back at the command line, AWS EC2. Don't need IAM permissions to see this. I just need EC2 permissions. Very often people think a lot of EC2 permissions on EC2 instances are safe. They are not. And again, this is not a read, this is not a write, it's a describe. So there's a theme here. As a bad guy, as a hacker, I'm going to use lists and describes. I'm going to be doing discovery. Okay, let's go look at the instance profile associations. All right, so all I'm doing here, if you think about that EC2 instance having that connection to maintenance role, I'm looking at the thing that is the connection here, okay? The association of these. And there's a little bit of data in here. So the instance ID here is the instance ID of the EC2 instance I'm working from. The state is that it is in fact associated, so it's connected. And then what I'm really going for here is this association ID. I want to be able to point to this association so that I can change it. Okay, so I'm going to grab this and I'm going to go over to my text editor here off screen, because this next command is really a mouthful. And I'm going to explain the whole thing. This is, if you read the DOJ filing on the Capital One breach, you'll see there's a part in there in which the hacker says that they do an IAM assume role. That's this. Okay, that's what this is. So it's a mouthful and it gets really verbose, but I want to walk through it so you really understand what I'm about to do. So AWS CLI command. Again, we're pointing at EC2. All I need is EC2. I don't need IAM, right? Remember that when you're granting EC2 permissions. There are some scary ones. So the EC2 command here, the action is called replace IAM instance profile association. It's a mouthful. It does what it says. It replaces that association with another association. So I need to know the association. That's why I looked this up. So I pass that in here under association ID, replace that one, and then replace it with the IAM instance profile whose name is S3 read write. So you can see here, we're pointing at maintenance role. I want to point at S3 read write role. Okay, let's see if this flies. All right, that looks like victory. This is how sad we are as hackers, whether we're white hats or black hats. This is like this moment right here. Okay, you've now got a new association ID. You can see that doesn't end in the same thing, right, as this one. And it's pointed at S3 read write. So I should be able to see S3 now. So let's go back to the very beginning and do our AWS S3 list. Now I can see data. Now I can list the data. Okay. So remember I said I was going to exploit an open firewall port. I was mostly going to be exploiting IAM to get to S3 to steal from S3. Okay. And I can see here this important records is an attractively named S3 bucket. Sounds like stuff I might want to steal in there. So I'm going to do an AWS S3 LS of S3 important records. Oh, and if I could type properly, and I typed S2 too. I just switched keyboards. I shouldn't have done that. All right, so now we're getting an enumeration of the data that's in that bucket. Now, in this case, these are some pictures I took in Iceland. No big deal, right? This is me just hacking around with my own account, trying out hacking techniques. But in the real world, this was like a lot of customer data out of that bank, a lot. So what I've done here, back to the diagram, I got into here, and by using different API commands, looking at doing discovery via the metadata service, but that was a tiny part of this hack, right? The big part of the hack is doing discovery via EC2 and IAM of other IAM roles, and then exploiting a misconfiguration in the IAM role on the EC2 instance to change the IAM role. And now I can see important records here. And what I'm going to do next is I'm going to steal all the data out of important records into my own S3 bucket called all your base. All right. So we know from the DOJ filing exactly how this was done. It was done using a command called sync. Now, so AWS S3 sync. Sync is not part of the S3 API. Sync is only a convenience utility that's built into the command line. So we know the hacker was using the command line. A lot of the news stories on that breach thought she was doing something on like some remote server somewhere else. We know she got in. We know she used an IAM assume role just like I did, and then used sync. Now, the beauty of sync, so I'm going to do important records. Let's see. I'll watch myself type this time so I don't have typos. I'm going from S3 important records to, I need an extra slash down. I always thought that slash thing was kind of goofy in URIs of all forms. From S3 important records to S3 all your base. All right. I just stole all your data. And none of it traversed your network boundaries. Not a single bit of that data theft traversed any of your intrusion detection systems, traverse any of your packet monitors, your firewalls, your VPC gateways, nothing. It went straight from S3 to S3 on the AWS backplane. Okay, so this is why so many S3 breaches go undetected. Because what evidence do you have that this was taking place? Really, the only thing you have are the log entries of that sync command performing gets. Right behind the scenes, all sync is doing is it's using S3 list. Another reason you should not have S3 list turned on anywhere in production. It's using S3 list to get a list of things, and then it's doing parallelized copies to another S3 behind the scenes. So you'll have some API calls, you'll have some gets, but what's S3's job in the world? It's like a fourth of the internet. It's really good at handling lots and lots of gets. So finding that needle in the haystack, even if it's stealing all of your customer data, because what those S3 buckets are probably doing all day is serving customer data to legitimate actors. So what's another million calls against your S3 infrastructure when you're doing 200 million calls a day against it? It's very hard to see. And so this is why getting the configuration right to begin with, and then keeping it correct through automated remediation is so important. If I had had Fugue turned on in this account doing automated remediation, it would have caught when I did that IAM role change, and it would have reverted it. Okay, so instead of my being able to go and break into S3 and steal all your data, I might have momentarily been able to see a list of S3, but then Fugue would put it back to maintenance role and shut down my ability to do the copy of the data. Okay, so so that's the demo today. I think we've got a few closing slides here. Yeah, just to recap. So the misconfiguration attack and review. First, there was a firewall misconfiguration I could get to, and I could use my automation tools to discover a vulnerable EC2 instance. Number two, I had a vulnerable EC2 instance. Second mistake. So usually, in this case, I believe it was due to what we call orphan or zombie infrastructure, stuff you've forgotten to patch anymore. So I break in. Right, I get my toehold. Number three, I needed to find a way to get an IAM role that could access S3. And the permissions on the IAM role that EC2 instance had were such that I could do that. And then four, I had to discover the S3 buckets and list their contents and sync and steal their data. So some recommendations. Monitor all your access point configurations. You should really have full visibility into your ingress ports to the internet, or even not just to the internet, to any kind of broad external CIDR block, right? A lot of people miss that. Obviously, you want to use least permissive permissions on all this stuff, but really apply that to IAM. Don't use star in IAM ever. You can use things like different endpoints with different IAM roles for read and write operations too, right? And get rid of anything in the production environment that relies on lists in S3. Shove that data in a database and query it there. IAM list permissions in production are extraordinarily dangerous, as I hope I just showed you. And yeah, don't allow EC2 instances to have IAM roles that allow role assumption. It's game over. Get rid of unused cloud resources, especially EC2 instances, S3 buckets, but also think about things like EBS volume backups. And if any of those are public and unencrypted, because often they contain secrets, you need to constantly clean up behind yourself and only have out there in cloud what you need to operate your business. And that means you have to know everything you have out there. And I can almost guarantee you, you have stuff out there you don't know about if you're operating at scale. Include cloud misconfiguration and pen testing. You know, I don't even love the term pen testing. What we tend to do is use things like HackerOne to just get to put bounties on finding stuff in our non-prod environments and getting the cleverest bad guys out there. Right, everything in the hack I just showed you, none of it. I never got root on the operating system. I didn't do any of the traditional hacker stuff. I completely exploited cloud misconfiguration, and good luck finding that in a single team. So you have to be creative there and find people who really know how to do it. Use automated remediation. Again, if we had Fugue turned on in that environment in remediation mode and in automated remediation mode, enforcement mode, I would have been prevented from stealing the data. You want something like that. We have a free version you can use up to a certain scale, but you can do it other ways too. Obviously, we think our approach is best, but do something, right? And then you can use things like Open Policy Agent. And I've got another talk in this series of sessions on Open Policy Agent for finding these problems. But you need some kind of policy as code to tell you. And we bake into Fugue, when we learn how one of these exploits happens, we add rules into Fugue. I told you the compliance frameworks don't really think about things like IAM role assumption. Well, the Fugue best practices does, because we saw that bad guys are using this, so we build in the rule. All right, we're not going to do live Q&A, but here's our web address. That's my personal email address. Feel free to reach out. I love talking to folks about this stuff. And yeah, thanks very much for your time.